data analytics domain. Yeah, so again, the same rules. If you have any questions, like make sure you put them across. But we can't take a lot of questions because we're already out of time. Yeah, can start.
Uh, Good afternoon, everyone. It's 12 o'clock. I hope all of you are sort of wide awake. We'll try to make it as interesting as possible. No jargons. That's the first thumb of rule that we followed. So hopefully this will be useful for you going forward. Um, so I'm Devangana. She's Kokila. We both are from ThoughtWorks, Banglore. And from quite some time, we have been working on the data analytics space. And this is a very different thing that we tried in terms of testing on this particular project that we have been working on. And there are some key learnings from that project, which we wanted to share with all of you. One disclaimer, whatever we are sharing here is project agnostic. So this would be valid for any one of you who's going to work on any of the data analytics domains. I'll start with a brief introduction to data analytics. It's a buzzword in the town, but I'm pretty sure most of you are already familiar with what it is. But still, so data analytics is basically a process of collecting and processing data, coming up with interesting insights from it, which are typically revolving around certain business problem. Right? The data analytics could be either exploratory data analysis, wherein you start with something without having a specific problem objective in mind, and you sort of do some sort of exploration to find certain patterns. And then based on that exploration, you define a problem statement. Or you can start with a problem statement, say, how many of you have heard about market basket analysis? Okay, so this is basically a process wherein the supermarkets try to find out what products are being bought together in the market, right? So there they have a problem objective in mind, and that's how they start their exploration. So depending on what you're looking at, data analytics would differ. So as I said, the first step is the data collection step. The data collection could be done from different sources. It could be the social media websites like Yelp, Facebook, Twitter. Your databases, they can be sensor data, satellite data. You can have survey results. So there are different sources from where you can look for data collection. So this is the collection process. The next is the processing process, wherein you bring together data from different sources and modify it, transform it to a standard format that could be ingested by your application. So you do a whole lot of cleaning up, transformation into a single format, putting into a tabular structure and all of that. The next step is the modeling step. So basically you have some sort of available data and you try to fit in mathematical models on top of this data, which would describe this data. So a mathematical model is nothing but a function that gives the output as a function of a input, right? So you have certain input going into your system, you have certain output coming out of the system, and this is defined using a mathematical model or some other model, and that process is called as modeling. The next step is the inference step, wherein you use this model on the new data that you get to find the output. Right? Now the output that you get, this is the output that model spits out. And this result directly cannot be, probably is not useful for the customer, right? Usually who are the customers? They're probably the business folks, right? And who do not understand the language of mathematics. So you probably have to transform it into you have to weave a story around it. You have to bring together the results, all the numbers together, and then sort of present it to the user. And this basically differs from the domain to domain. So this is the buzzword in the industry, right? Everywhere you go, you would definitely hear about big data, data analytics and stuff. Can I just quickly have certain use cases of these data analytics? Like what are business domains is data used in?
Stock markets.
Exactly.
Sentimental analysis.
Right.
E-commerce.
Right. Weather forecasting, absolutely correct.
Cost-related data in manufacturing industry.
Exactly. So there is like n number of use cases you can fit around it. There's basically no end to it. So I've just put together some of these use cases. Business intelligence, sort of doing analytics around your business, right? Social network analysis, finding who's your possible friend. You get suggestion on Facebook, right? On friend, you may know this person, right? That's data analytics. Astronomy, astrophysics, computer graphics. How many of you know what that is?
Google. With the invention of Google,
Google.
which drives itself.
Exactly, the self-driving cars, right? They sort of visualize the surrounding them around them, and they drive themselves. You don't need a driver, human driver for these cars. Energy exploration, medical imaging, finance and stock market, life sciences, robotics, and these are just probably 0.1% of the total use cases you can probably list down for data, right? Um, yes. So now we are in vodka, we're talking about testing. So Kokila is going to tell you why testing is important in the data analytics space.
So we just saw that data analytics is the lifeline of any business. So for any sustainable or progressive business, data analytics is very crucial. So they need to understand the data that they have, and they also need to come to a proper analysis and see how can they progress in that data. So data analytics in itself has various complexities involved in it. It might be the data volume that you are dealing with, the variance of the data, the data diversity that you might have to deal with, and the computations or the statistical model that you would choose to infer the result that you are interested in. Adding to all this, testing also is a very crucial part to ensure that all of these complexities are tackled in the right way. So that, data only makes sense if it serves the intended purpose, right? So how do we ensure that this with respect to the product or the system that we are developing, how would we deliver the quality data so that the business is really making some sense out of it or some get some value out of it. Uh, Next thing is let's see the various challenges that we see in the data analytics testing space. Given the fact that we collect the data from various sources in various different formats, as you mentioned, it might be a satellite data, a survey data, or whatever. Right? So we might have to do some basic initial sanity checks even before we start processing the data. Any thought process on what level of or what checks we need to do at very initial stage?
Check some format.
Formats.
It means the data before.
Yes, or data cleansing. Right. Basically, format would be the first thing, right? Given that we might receive data in a survey or a CSV format, we need to first be clear about what sort of data we are receiving. Is it a text data, or is it like a CSV format, or would it be like a satellite or a imagery data, image format? So it might be anything. So we have to be clear of what sort of data that we collect. And the format checks basically. If you are receiving it in a text format, what is the case consistency? Would it be in a camel case? If it's a number, okay, what sort of number field is it? Would it support decimal values or just whole numbers? If it is a decimal, to what extent or what precision level are we expecting the data to be? Similarly, the date field, right? What is the format of the date? DDMMYY or something else. So the first check would be something around the formatting or data validation check. So what really matters here is if we see in the whole of the data analysis process that Devangana just explained, data forms a very key aspect. Right? So the data undergoes a series of various transformation and it various stages basically, right from the collection, the processing, and then applying the statistical model, and also final visual representation. So validating the data at each and every stage would be a very crucial aspect of it. The next challenge here would be the model implementation. This is a very crucial part for any analytics system. So first of all, what is the model that we are choosing to solve the problem? Are we choosing the right model for the domain that we are really looking at? Okay. So, in order to validate that, we need a thorough and very detailed understanding of the domain or the problem statement that we are trying to solve. Let's say we choose a statistical model to solve a problem. We need to understand the model thoroughly as well. So, to understand the model thoroughly, to get in detail to the model parameters that are involved, what are these parameters? How are they mapping to the real world data? Are we mapping it in the right way? This is the sort of understanding that we need to have, both in terms of the domain and also in terms of the model that we choose. And next question. Yeah.
So why is the choice of model a testing challenge? Would it not be a part? Would it not be a? I mean, when the application is being built at that point of time, the designers would have chosen a particular model, and from the testing point of view, it would be necessary to test the application both as well.
Fair enough. But let's say there is a model which has some algorithm in it, right? Some kind of a statistical formula which you need to implement. If we don't have thorough understanding of the model parameters, so the model parameters there would be from a data science background. How could you relate it to the domain that you are dealing with? Right? So these to see if you are mapping it in the right way. So this is where you require a thorough understanding of the model in itself. You are right. Maybe the model, let's say for a particular domain there is a well-known model which is out there. But understanding the model so that we interpret it correctly, we interpret the model parameters right, and also throughout the computation, to ensuring that the computation is happening right. So in order to tackle this problem, testing, from the tester's point of view, it's very important to understand the model that we choose.
So this is basically understanding of the model, not really implementation of the model.
It involves both the things. So as I said, it's a three-step thing. Right? First, you require the thorough domain understanding to understand, like what is the problem that we are trying to solve. So what is the domain? How is the data? What format of data that we have? The next is the model. The model that we choose, how relevant results would be there when we apply for a particular domain. Just so that it's easy for you to relate. Let's say we have some predictive model, where we have some past data, and we'll predict some sales or some sort of profit for the future data. We have a model in place. How could we validate if this is accurate? So probably we can choose 1 year of the past data, apply this model on 3 quarters. So for the 4th quarter, we also have the expected data, and also we can have the model output. So that we can do a one-to-one comparison, see what is the variance.
It's basically around the choice of model that has been made. So that choice will be made upfront itself, right? And you're implementing that model. Now, if the model itself has been correctly implemented or not, that is the testing that we're talking about, not on the choice of the model itself.
The next would be the business perspective. Let's say a typical retail app or a banking user, it's quite easy to mimic the end user so that we will also be using this application. But the challenge here is to get the perspective from the business. To have a clear visibility on what is the problem with the user or the business is trying to solve. What is the key factor that the business would like to consider? Is it like spreading the market, growth of a market, or whatever? Like you need to get that vision perspective when you are working as a tester to see if the value or the product delivers value. So what sort of results? We have the data, then we have the model and statistical implementation. We infer some of the values. How well we can represent this as an output to the end user. So in the form of like charts or graphs or some tablet. What sort of data would be more usable or more intuitive for the end user to make informed decisions? Devangana would explain the information.
So before we move on to the actual testing, I'll just quickly take you through the typical data analytics system implementation. This is very much similar to the first one that I covered, but this is less generic. So we talked about the collection part, right? Try to retrofit this particular system implementation to what we saw in the first slide. So the first process was the data collection. So this is where your source data, the raw data comes into picture. Right? This raw data has to be transformed into a standardized format. What was the process called? Processes. Okay, so the raw data has to be converted into a standard format, which basically includes extracting the required data. Not all the data might be required for you. Transform it into a standard format, and then finally load it into a database that your application is using. Right. So this is where you have the usable standard data ready. Now the next process is the simulation, which basically consumes the model that you have already implemented and the data that you would fetch from the database, combine it together to come up with the outputs. So simulation is basically finding outputs by deploying the model on the data that is there in your database. Now, this would probably be done at, say, a leaf level, right? Wherever the row level or column level, whatever granularity you are looking at. But then that is not something that you would be looking at. You would be looking at some sort of aggregation on top of it. So this aggregation step comes there. So this is like post-simulation step that you would call it. And finally, visualizing it in a format that that makes sense according to your business. If it's GIS data, map data, you would want to put it in a pictorial map format. If it's a business, IT business, right, you would probably want to put it in charts or bar graphs and stuff. So depending on what sort of domain you're looking at, you'll come up with visualizations. So this is a very generic implementation of a data analytics system. This would definitely differ. It will have its own nuances when you are working on a project, but this would be a typical flow of the system. So yeah, now this itself, even though it's generic, it's complex, right? There's a lot of stuff involved in it. So what we tried doing is sort of come up with a very simple approach rather than looking at a very complex one to see if we can solve the problem of a thorough testing in this particular domain. I come from an analytics background, and first rule of thumb that is taught to us is keep your model simple. Complex models do not always solve the problem. That's something that we tried using here. So what we did is we divided and conquered our testing approach. So there's a lot of transformation that is happening in every step in this particular system, right? So what we thought was, why not divide this entire transformation life cycle into small steps and then test it every step. Every transformational stage has its own transformation rules, its own nuances, and you would want to deal with them at that particular level, and that is exactly what we tried. So Kokila is going to take you through each and every single transformational testing that we did and how we did it.
Uh, so the pre-ETL validations. So even before the data is fed into our analysis system for the ETL process, it requires to do some basic sanity check. We pretty much discussed a few of those for the 5 seconds. One is the format, which we are familiar, we just discussed. Also comes the data consistency. What's data consistency? Let's take an example like where we receive some sort of banking data. In one of the tables, maybe a user is inactive, but a credit card user's credit card might be inactive. And in another table, it might show that there is some balance among users in credit card. So the data is not consistent here, right? It can't be in that state even before. So these are the kind of checks that we need to have with respect to the consistency. And data completeness. Let's take an example of a retail store, wherein we have an inventory data which says for a given month's time period, we have some 10 units of a X product, right? And by the end of the month, if there are only 5 units remaining, and if there is also a corresponding sales data, that should represent for the sales of this 5 units which are missing. So if there is some mismatch here, then there's some data missing somewhere. So data is not complete. So these are the very initial checks that we could see if the data that we are receiving is of the right one. In our case, what we did was we implemented this with the Excel VB macros. So Excel is pretty much a well-known format for the data. So what are the data that we received? We validly introduced some Excel VB macros to have these basic initial level sanity checks. Next, coming to the post-ETL test. Once we collect the initial set of data, we need to represent that data in a form where our analysis systems would be easily reading this data. Right? So, what are the type of checks that goes into this process after the transformation stage? The metadata checks. So, how are we modeling our data to fit the real world data? Right? How do we define our tables? The data length checks, the data type checks, and also some unique key constraints. Let's see if there is any mistake that we do in defining the database tables itself. Let's say the numeric field, the precision that we give it in a smaller value, but actual data is of much. So the precision for all the computations would remain, which it would remain faulty, right? So a mistake in this stage might lead to incorrect numbers going through the process. Next comes the data transformation. So data transformation here, it's very important to see that the data that after transformation is as per the expected value. Transformation might not be really a one-to-one mapping. It might involve some transformation rules also. To give an example so that you could relate, let's say there is an electronic device which will read some data every 1 hour. Okay? And this data is from an external system and it would be specified as one column in a table. So from the source data, we receive it in an XML which is represented as one column in a table. But after transformation, probably we would want to interpret this one column value into a series of records. If an XML file might have like 24 for every day, it might have 24 XML tag, right? Attributes saying what are the list of attributes or the data that it is preparing. If you want to map this into each and every row in the Tableau database, so there is some kind of a transformation rule that goes in. So we might have to ensure that all these transformation rules are also incorporated. properly. Next comes the data quality checks. This is the core data testing basically. So the source and the destination mapping should be right. There should be no loss of data. These are the pretty much the basic tests that we do in any data related project. The test cases, the special character shouldn't get missed. The number precision should be detailed. So if there is a decimal separator or thousand separator, that should be integrated correctly. There should be no data loss. So these are the various checks that we do. Also, with respect to the constraints, right, like the unique key constraints or the reference key values. So it should still, the transform data or the target database should still avail to all of the constraints that we are defining here. There might also be some business specific checks. For example, let's take the banking domain ID. A user who can own a self account holder, the age of that user should be greater than 18. This is something like a very specific business check. So from domain to domain, these kind of checks might vary. So after the data transformation and we have the data in the target database, these are the various sorts of data checks that we might have to. So in our case, we implemented it with by querying the database once the transformation happens, and using the Python language. We have a set of SQL queries which would test on this data and ensure that there is no data loss from the source to the target mapping. When the data volume is involved, it's pretty much complex to ensure that the source and the target data is still intact. You usually use some kind of an aggregate queries to ensure that the count in the source and the target. Let's say if it's a numeric field, the summation value of from the source and the target, if these are matched.
One question I have is against what you are validating is like this against the set data, you know that okay for this set of because in data cases, right, it's like a huge set of data which we are dealing with. So here if the data is small, you know that what could be predicted as an output, right? Whereas when what was the validation, what against which this is gonna be if this is the output, I'm expecting it to be true or false. So how happening in this?
Yeah. So definitely the checks to ensure that there is no data loss. As I mentioned, we use some sort of summarized data verification. Like the source under target, the count of the rows in the source needs to be certain. But they might also involve some kind of a logic building also. As I gave you the example of an XML, some sort of passing the XML, the number of nodes that are there. So that each of these nodes we should translate as every corresponding record of the target database.
Was it a controlled data set you're feeding in for the testing purposes?
Yes. So we decided a subset of data which would have the possible diversity that we could think of, and we did test it.
So at least till this particular step, it's our absolute testing. There's no relative testing. You do not validate the results corresponding to something else. So like she gave an example of age, right? That's something which is domain specific, and that sort of check would be absolute check. You're checking if the age is greater than or equal to 18. So there's no relative check here. But yes, going forward in the pipeline, we'll definitely have those checks, and that's where we use a control data set for this.
So your test is the check or you're testing that the check is working?
No, the tests themselves are checks. So those checks are basically validations,
Yeah.
as well as
And that's part of the application.
it's part of the application. Yes.
It's not part of your testing application. I mean,
Can you go to the previous one?
So one point to note here is we haven't even started the analytics part of it. So far, it's just the data collection and representing the data in the database such that the whole analysis or the inference model will be able to read it in the right way.
correct. So what are we testing? We're testing that this is happening or we are
We are testing that the ETL process is working as well. It's not the analysis model testing that we are doing, so we are still testing the ETL process in it. It's not the final application. That's why, as you mentioned, it's the divide and conquer. We want to introduce testing at each and every transformation status of data.
So, how to validate the unstructured data only, like Twitter, tweets, or Facebook likes. So, in this case, we are validating the structured data, like row counts and the data difference orders. So, in unstructured database.
So one thing which we are working with structured data so far, but then in the past I worked on one of the data where we were collecting Twitter feeds. So there you probably might not have business specific validation, but you might have tests that are very specific to it. Things like whether the data that I extract out of these tweets is alphanumeric data. There are no special characters in it, or there are no characters from the different like Chinese characters or something of that sort. So that would differ, and that will have to be specified based on what problem you're looking at solving and what data you are ingesting. So this is not specific. Like you need not have all of this in your particular case.
I have a query here. So, general ETL process, I don't have much idea about ETL process, but I have heard from my friends that during this process, many times data gets corrupt, right? So, what preventions have you done, or is your process taking care of this data corruption as
So
well?
this is why we had pre-ETL and post-ETL. One very simple example. Say you have a field that takes only numeric data and no decimal part. But somehow in the data you have decimal parts coming in, right? And so this will not fail. This will still load it, but probably if you have something like 10.5, it'll just make it 10 because it's numeric column, right? But then when you perform aggregations and all of that on top of it, you find that the sum of all of that is not basically becoming equal to the sum of this. So we have put all of those checks also.
Only would like to add one point there. As I mentioned, like the aggregation of data, right? So once the ETL process is done, we might have to use some kind of a statistics method to see if the data is transformed correctly. Let's say we have a time series data. Once after the transformed data, probably we might try to represent it in a graph. And if we see like in a pattern of the graph there, and for some particular week, let's say it's a weekly data or a monthly data. If we see a very anomaly in the graph, it's much higher than other data. Probably there might be something which is going wrong there. Right? So these just an example to see analyze the data if it's in the given range or if there is anything very evidently that something might be going wrong. These sort of checks we might have to do.
This model especially works when the type of data or complexity level is known to the customer. What do you do when the data is dynamic? First, when the volume is growing. Second, what is the scope of automation here? I understand when you go to the drill down chart, the charts and all, using the UI and the tools, you can, with something like Selenium or any tool, you can automate that process of data validation. But this process of extracting and transforming the data, other than ETL tools, are there any other, is there any other way of automating it? If yes, how much of it can be automated?
Yeah, probably to answer precisely your point, we have covered few of these things in our subsequent slide. Okay, it might be a tool that we have tried differently, or the process wise, or the approach to handle this. Probably few of these would be answered in your subsequent slides. If not, you can.
So probably we'll come back to your question once the presentation is over. So the next one is the simulation validation. Simulation is basically using your model that you have on the data that is coming in to come up with the outputs. Right? How many of you remember the dreadful proof that LHS is equal to RHS from high school? Right? So what do you do there? You start with LHS, do stepwise computation, and finally try to arrive at RHS. Or if you don't, you just write equal to RHS. So the teacher would give you numbers. So that is exactly what we try to do here, right? So if y is equal to f of x, y is a function of x, output is a function of x, it need not be a single step transformation, right? You'll have stepwise computations. So what we try to do is we try to check these computations at every single step. So if there are 5 steps to get the final y is equal to f of x, we check each and every single step. It makes our life very easy. One, we are checking very small focused things, and if there is a bug, we'll identify it at the right stage rather than repeating the entire process again. We also check for the model validation whether the formulae themselves have been implemented correctly, right? The dev might be having a difficult day and he might have screwed up the equation, so that would give us incorrect results. So we have that understanding, we get that understanding from the business and try to check if what exactly has been coded is what was defined by a data scientist or the business. Right? So these two cover that, and I've already mentioned the computation. So we've used C# and something called a spreadsheet gear over here. So spreadsheet gear is nothing but an interface between Microsoft Excel and the database. So what we do is using C# scripts, we take a dump of the entire database, put it into Excel. So this dump includes the inputs, all the parameters that you might have for the model, and the outputs. What we do is using Excel formulae, which are written in the C#, which are embedded in the C# scripts. It automatically computes these stepwise computations using Excel formulae, and then tries to compare these stepwise computational results from the database with what we have done with Excel. So it's like you're trying to define the Excel as the source of ground truth, and then you're checking everything against it. And on top of that, we can put certain statistical matrices like root mean square error. If there is an error between the expected and the obtained data, how severe it is and all of that. The next is the aggregation validations. Now you might be doing aggregations at different levels. Real estate example I'll take here. So say you have different plots for sale in Pune, and the price of this plot is a function of certain attributes, say the locality, the area size, and all of that. Right? And you do this computation of the price for every single plot. Now you might be doing aggregation at different steps. So you can have different hierarchies. Say I want to find the total price of plots in the Pune region, or you can say in the Vimannagar region. So you can have different hierarchies in terms of geography, or you can say I want to find the total price of all the plots which are bigger than some X square meter size. So that is a different hierarchy you would look at. Different scope. I want to focus only at the Viman Nagar plots. I want to focus only at the Kalyani Nagar plots. And then you perform summarization, you perform aggregation based on these different hierarchies and scope. So you have to validate if we are applying these hierarchies and these scope, are we doing, is it happening correctly, and are we getting the right aggregated values? So we have used REST Sharp, C Sharp, and NUnit to do that. We have a specific data set in mind. We know what are the expected results that we might obtain. We create different snapshots of this data according to different hierarchies and different scopes. And then we define that these are the aggregated values that are going to come out of the system. And then we check if these are actually happening correctly or not. And finally, we have the UI validation, right? This is the most important factor, which a lot of people forget when they go for a data analytics system. You might build up the most sophisticated system in the world, but if it's not friendly to the user, it doesn't make any sense, right? And there are a lot of progressive actions that it means the testing community is taking here. Say, it was never talked about how would a colorblind person basically look at these validations, right? But people have started looking into all of that. So those are the sort of UI validations that we would make, and we have done the automation using C Sharp and Unit and Selenium. Some key learnings which Kokila would be quickly taking you through.
So if we take a typical agile activity development life cycle, we'll just share the learnings that we have in various projects. In the analysis phase, what did we really do differently? So as we just discussed, like the initial data flow into our system, we wanted to validate it, even before it was our system. So we kind of defined a predefined template saying that this is the format of the data, this is the various tabular structure that we expect, and this table should have, or this column should have a numeric field. So a clear definition between the external team from where we get the data, and so that it will be well intact for the processing. Also, we did have the pre-ETL validations as we just explained. So the Excel VBA macros, so that even before it reaches our system, the external data team could run this VBA macros at their end, so that there will be less of a turnaround time between the fixing the data. The next thing is the domain knowledge in itself. We just discussed how complex or how important it is to have the domain knowledge and as well as the model understanding. We did have frequent KT sessions among the team, and we tried to involve the SME just to validate that our understanding is right with respect to the domain and the statistical method. Or as a team, probably we might be of some understanding which might be wrong, and we might be testing a wrong product in a right way. So just to ensure that doesn't happen, we involve the SMEs to validate our understanding. And also for the code computation, what we tried differently was we selected a smaller data set in Excel, we try to mimic the computation what the application need to do. As an exercise, right? We try to do both the devs and the QA so that we'll get a clear understanding of the step-by-step computation. So even for implementation or for the validation, we are clear with what we are trying to do. Next comes the business involvement. So typically, we involve the business at the requirement gathering phase, and also in the agile where we showcase it every iterative model, iterative product development to the business and get feedback from them. Right? So we try to involve the business little more than that. So we developed our application with a smaller or a demo kind of a data with some data assumption in mind. But as we developed the product, we wanted the data set to be more closer to the real world scenario. So we took the business help to get a more closer data to the real world, so that they would have a better understanding. They are more facing to the external world. They have a better idea of what data that they would have. So they help us in getting the data set also. Also the user flows. As I already mentioned, if it's a typical web app that in common man would use, it would be easy to try out the user flows or to imitate the user and try out various flows. But the company vision or the business vision might be something different. So we wanted them to come up with or prioritize our test cases so that they would have a clear vision of what they're trying to solve. They would know what are the typical scenarios or the common scenarios as a business or they would be trying to solve. So we got these test cases also prioritized as a user. Next, coming to the implementation phase itself, right? Computation. Okay. I would just like to give an example here. We started developing with a demo kind of a data. Then we wanted to try it out with a different data set, which is slightly bigger. When we started doing that, we faced a problem wherein our computation were taking really long, and it was not even succeeding for that matter. So we did try to start addressing the problem of big data, the performance issues here, the computational time, what hardware does it require, what memory, CPU, or the RAM size does it require. But we stopped for a while, we paused a while, and we took a step back and tried to understand what is that which is causing the data to explode in such a big data size. So we receive our data in CSV file, which is of 10 MB, and the final target database after the transformation would be in 500 GB. So we wanted to understand this transformation process much more clearly. As I said, there was an example of a transformation group. Probably we wanted to understand that in more detail and to see during the transformation, is the data explosion happening properly? Are the table joining right? Is it happening in the right hierarchy? This kind of helped us to solve the problem much going forward, because there was really an issue wherein we were not joining the tables at the right hierarchy, and that was one of the causes for the data to be exploded in much more than what we anticipated. So this is where we took a different approach to understand the problem and to address the right problem even before trying to fix that problem. And the computational factors, right? So the statistical model or the formula, we need to have a thorough understanding. Also, let's take the computation is really taking a longer time. Okay. How do you even benchmark what sort of, for given a data, what is the time that execution might take, or what is the hardware capacity or the RAM capacity that we need? Let's say we have our data for 1 year. Okay. We have a data for 3 months. And if 3 months of data computation will take X amount of time, it might be a wrong assumption to say that this 1 year data would take 4 times of the X time period. Right? It might not really be that which is actually involved in the computation. Maybe there might be some other factors which would contribute to the execution time or the hardware or CPU usage. So we try to understand that also by trying out the various data sets and seeing what sort of data would really contribute to the computational time or the resource usage as well. The implementation, Devangana pretty much touched this, right?
How you take it, that computation?
So as I mentioned, we thought, okay, we have size for, we have the data with so many number of records. Let's see if this is explored much more. We assume that, this might take much more time. But what really helps us is, like the computational algorithms, trying to understand that in detail. It might not be really the number of records that matter, but let's take the hierarchy. She gave an example of a real estate, right? So if we are tackling the problem such a way that we are computing something at a very granular level, I'll take a crude example. Let's say like the city level. Okay, if that is involved, so the factors involved here might be much more for computing the real estate trends than if you try to see it at a state level, for example. Because here the factors, like let's say for every state, you might have to consider so many other dimensions to see really if this is taking what sort of trend that a real estate market is showing. So it might not be the past 1 year data or past 3 months data that matters. It's more of what level of hierarchy within the data that you really need to focus to get the actual computation.
And how you control over the system performance, like whether it is able to compute all this data in a particular time or something.
So yeah, probably I'd like to answer this question, but specifically we try to avoid the whole focus towards the big data or the performance aspect. We just focus it towards analysis. Probably post this will take your question.
Just one very small thing. One thing which we tried in terms of the performance was that when we faced this issue, we wanted to understand how is how is the time factor dependent on the size of data. So we came up with different complex data sets, like a small data set, one with a lot of interdependencies and all of that stuff, and different size data, and sort of try to create a heuristics around it. And we use that to sort of predict that if we get certain size of data and it is supposed to take X hours and it's taking 100 X hours, then there's something wrong with it. But not in very detail, but this was just some sort of analysis that we wanted to do.
Yeah. I don't want to deviate much because you don't want to focus on performance now, but still, when you're talking about performance, how do you actually distribute the load here? What is the load pattern? Is it just the volume of data and measure the time, response time, or also the number of concurrent users? Because that also multiplies, right?
Yeah, we haven't gone to the user.
Probably the two factors that you mentioned, but then like the load of the data plus the number of users, and a very important factor to consider for the data analytics performance itself is the data diversity. So, what is the possible combinations of data that you get? So, because certain computations might involve in the various sizes of data, right? So, this is again now something that.
One question here. I mean, the project uses ETL as a process as such. So, I mean, before taking a decision, I mean, I understand we use Excel as the primary ETL tool here. So, did we do a POC of any available tools like Abhilash or Informatica? Was there a cost factor involved?
No, so we didn't want to go with a sophisticated tool because we wanted to use a tool that will be easier to use for us as well as for business. We can implement all of this, say, in R or in Python, right? But then the business, a user who gets confused when you put 5 buttons in the remote instead of 2, if you present them these scripts and these sophisticated results, they won't be able to validate. So we want to validate our results even with the business, and Excel is like the single short solution for all of that.
So that was the whole idea of choosing Excel VB macros, and like even for the simulation testing that she explained, we use spreadsheet getter, which provides a way to inject the Excel formulas into the Excel template through C#. So that we could input down the input data and the step-by-step formulas which are injected into the Excel worksheet would mimic the computation. It's like an alternate parallel implementation. That was exactly what I was about to say. So, because given the complexity of the data and the computational complexity, there is no easy way to come up with the expected data set, right? So what we did was like an alternate implementation. So we used Excel so that we would inject the formula and generate some sort of an expected result. The reason behind this is one, we might know, let's say there's something which is going wrong, either with the testing implementation or with the application. We don't know which is the right one. But we wanted the business or the data team to get involved in it and validate what is the right approach. So Excel being a very easy language for them to understand, and we go through the step-by-step computation and clearly point out where there is what is going on. So we choose that one, and we involve the business listening validation as well. So few learnings specifically in the testing. So this we pretty much went through. So we tackled the whole problem with a step-by-step approach. And also with respect to the defect investigation, right? What we did differently was for every defect that we found, there's some discrepancy. The QA and the dev pair together and try to understand the problem in more detail, because it gives two different perspectives of the understanding the whole model or the algorithm, and to see if what is going on. This also helps us a lot going through. Automation, we pretty much try to cover automation at each and every layer. Yeah. But the kind of data combinations that was required for our automation process was really huge. The analytics system that we built, it was designed in such a way that it has to facilitate multiple users with multiple backgrounds. When I say multiple platform, it might be different domain altogether, retail or something else, right? So coming up with a generic framework so that it could do the same validation, the same algorithm calculation with multiple data support. It might be varying data from the DB structure layer itself. Like let's say for a given domain, there might be some tables which might not be there for some other tables. The tabular hierarchy also might differ from one client or one user to other user with varying domain. So we built a generic framework of which supports the various data combination, and we add a way to provide the test data more in an XML way so that it will support the multiple users. Next comes the test data distribution itself. So the key challenge here is when we decide on a subset of data, how well we can come up with the smaller subset of data to test the whole process. Uh, we involve the business in this again, and we wanted to come up with like 20% of the possible test case, which covers 80% of the most commonly used scenarios. So that was the mindset that we had, and we validated the data distribution of the test data with the SME thing, even with respect to the edge case data set that might be possible. From a test execution point of view, uh, we add automation at every level, but we made a conscious decision to include what level of automation at what stages. For example, this being data intensive, we didn't want to have extensive UI coverage, probably a portion of UI automation testing, and it would add more value to have some amount of manual testing from the UI level, right? But it makes more sense in the other computational layers or at the service layer where the application happens. So that is one thing where we cautiously decided, what level of automation is required at each of these stages. And the execution frequency also. The computations are very data intensive. It takes too much of hardware and software utilization and even the time also. So we decided carefully like what level of these tests or what sort of test needs to be run very frequently in the CI. Okay, maybe we need not run for every build or every check-in, we need not run all the tests. It's the core computation. Unless there are many feature changes or many enhancements, we need not want to run all of these because it's like again it requires time and resource and effort as well. The testing tools we pretty much discussed this. So what is the choice of tools that we did differently? We could have very easily tested the core computation again with C# or NIV, but what we wanted to do is we wanted to validate this with the business. So we used the spreadsheet there so that even the business could get involved and validate. Similarly for the Excel macros. So our ETL being in Python, we could have done the initial set of validations in Python, but we choose Excel macros so that it provides an interface so that even the extended team could incorporate it there, and the data check or the initial testing happens much early in the life cycle. Yeah, these were two learnings. Just a quick summary.
So that's all that we had to share with you. This is just a gist of whatever we have covered. Just three main takeaways. Be pragmatic. There are certain things you just can't automate. Don't try to do that. Second, keep business in the center of your application. Keep users in the center of the application. And third, try to solve 80% of the problems with just 20% of the effort. So exhaustive testing makes sense in the non-data focused systems, but probably not in the data centric systems. You cannot do an exhaustive testing. Yes, so that's a fair statement.
Thanks a lot, Kokila and Devangana. If you have any more questions, again, so you can catch up with both of them outside. We have the lunch break right now. Lunch is served in the canteen, which is towards the right.